The example presented here involves a bridge with T-beams. Check how to determine the girders and the deck thickness here in bridge engineering. The bridge for this example has a length of 18 meters and total width of 9.6. It is a simple span with reinforced concrete T-beams type girders. We are tasked to compute the girder spacing, the deck thickness, and the number of girders. For the deck thickness, we have to know the bridge material. In this example, it is reinforced concrete. The girder type is T-beams. So for simple span, the minimum depth will be computed as 0.070 multiplied by the span. From the table, we are to use the thickness from 0.070 L. This becomes 0.07 of 18 meters or 1.26 meters. This is the total structural depth, and by the term structural depth, this includes the slab thickness as well as the girder depth. So we need to separate the two thicknesses. Let's figure out the slab thickness first. For RCT beams, the typical slab thickness ranges from 180 to 220 millimeters, and we assume the slab thickness initially as 200 mm, or 0.2 meters. So with the slab thickness already identified, we can have the rest of the structural depth be the girder depth. The girder depth is the total structural depth of 1.26 less the slab thickness of 0.2, giving 1.06 meters. Now we solve the girder parameters. Let's assume the girder spacing as 2 meters, basing it from the bridge material as reinforced concrete. Continue with the number of girders, which then is computed from 9.6 meters over 2 meters plus 1, which results to 5.8, rounded off to 6 girders. We can then compute for the actual girder spacing, which is 9.6 meters over 6 less 1, and this gives 1,920 millimeters, or 1.92 meters. With all parameters identified, we check the slab adequacy. With the actual girder spacing as 1.92 meters, the thickness ranges from 190 to 200, which means the thickness we assume as 200 mm is safe. Let's discuss this slab adequacy further. Since there isn't any simplified single equation for slab thickness, we use the preliminary table summarized from AASHTO provisions and common engineering practice. This shows the typical slab thickness with respect to girder spacing, which starts at 1.5 until 3.5 meters. At S of 1.92 meters, the range of slab thickness starts from 180 to 200 mm. So the assumed thickness of 200 millimeters is within the range. Another point considering is AASHTO's minimum deck thickness, which is typically 175 mm, or 7 inches for cast-in-place decks. The thickness we assume is 200 mm, which is greater than the minimum, so T is safe. The next point to consider is at girder spacing of 1.92 meters, the slab behaves like a short span beam, which brings about low bending moments. Thus, a thickness of 200 mm is sufficient to counter those moments. Lastly, thicker slab helps reduce cracking, improve durability, and resist wheel loads, so T of 200 makes the bridge safer. Since we are designing, Let's iterate the parameters with fewer girders. With the computed n of 6 girders, we reduce this into 5. The girder spacing then becomes 9.6 meters over 5 less 1, and that is 2.4 meters. From the preliminary table, S of 2.4 should have the slab thickness from 200 to 220 mm. So let's use slab thickness of 220 mm. Let's analyze this option. This slab becomes thicker again, at almost 9 inches, and also the girder spacing is at the upper limit, which makes it less efficient. How about iterating it with more girders? From n of 6 girders, we now use n of 7. The girder spacing is then computed as 9.6 meters over 7 minus 1, which results to 1.6 meters. From the table, 1.6 falls within the range of 1.5 to 2. Then the slab thickness ranges from 180 to 200 mm. Say we assume the thickness as 180 millimeters. Although T becomes less, there are more girders, which makes the construction costlier. With the numerous options, the adopted value for each parameter is placed in the table, where the span is 18 and the width is 9.6 meters as placed in the premise. The total depth is 1.26 meters, separated as slab thickness of 200 mm and girder depth of 1.06 meters. Then the girder spacing is 1.92 meters, making the number of girders 6. Now it's your turn to iterate. With a simple span bridge of length equal to 16 meters and width of 11.2, determine the parameters with reinforced concrete T-beams as girder type. There is an iteration in the solution, and don't forget to explore the plus and minus of girders. You should come up with the following parameter lengths and numbers. Good luck!